everyone, we are going to start our new unit, our second trig unit, and this is going to be an introduction to periodic functions. There are many examples of periodic functions. First of all, we want to think about what a periodic function is. So mathematically, a periodic function is a function in which the y values, or the answers, repeat at regular intervals. So in our diagram or our graph at the bottom, we notice that it follows the same W pattern. So we see that this pattern is repeating each time. That is what makes it periodic, is that we can follow, we have a y value down here of -3 at regular intervals. So each rotation, or what we call period, which we'll talk about in a moment, is the same. There are no deviations from the regular pattern. And some examples of that are the rising and setting of sun, phases of the moon. In a year, we follow the same pattern. Tide, motion of a Ferris wheel rotating around, as well as heartbeats, at rest or at a regular movement. Also light and sound waves, which you may have already talked about in science. Okay, so we're going to be looking at graphs where our pattern is consistent and regular. So looking at the same graph here, looking at some definitions that we need to know, some properties of periodic graphs. One complete pattern is called a cycle. Okay, so one cycle from our graph here is from where our pattern starts to where it ends and starts again. The horizontal length of a cycle is called the period. So when we talk about the period of a periodic function, that is sort of the start or distance horizontally from one cycle to the next cycle, and that's represented by a capital P. In our example above, we notice that we can start one cycle here, starts at 0 for x, and ends at 6 for x, so our period is 6 units. And we could start that anywhere. We could have talked about over here, -12 to -6 is a distance of 6 units, no matter where we talk about. Next definition is our amplitude. And the amplitude, which is measured by a capital A, is half the difference between the minimum value on our graph, which is a lowercase m, and the maximum value, which is a capital M. So our amplitude is basically measured as half the height of our graph. So in our example, our amplitude can be measured by taking our maximum value, subtracting our minimum value, and dividing by 2. So in this function, our maximum value is 5. our minimum value is -3. So we're going to subtract -3 and divide that by 2. So we notice that that turns into a plus when we're subtracting a negative. So we're going to have 8 divided by 2, which means the amplitude of this periodic function is 4. Now, in the same graph, for the example, y equals f at x, remember f at x is just our function, we are looking for the value of the function when x is 2. So we're going to look at our graph and look at where x is 2. Well, our graph or our value or y value here is -3 where x is 2. So f at 2 is equal to -3. For f at 8, again, going back to our graph, where x is 8, well, now our y value here is, also -3. So we have a y value of -3 for f at 8 as well. And notice that that makes sense because one full cycle has occurred in between. These are both the starting points for a cycle that we have measured. For f at 20, notice that we haven't gone up that far for x is 20. So what we want to do is sort of work our way backwards because we know it's going to be the same value as 6 units before that, 6 units before that, 6 units before that. We're going to have the same y value. So f at 20, we can look at subtracting 6 to go back a cycle. So f at 20 is the same as f at 14, is the same as f at 8. Well, notice we already have that value of f at 8 over here, which is going to be equal to -3. So f at 20 is equal to -3. And again, we're just working our way back, or in the next case, working our way forward by each cycle. So again, we don't have x equals -18 on our graph, but we know that it's going to be equal to, if we take our f at 18, and we're going to add now 6, and we don't necessarily have to do it in a whole bunch of steps. We can take -18 plus 3 cycles, or 3 times 16. So that means that we're going to have an equal spot as f at 0. Well, now we know that f at 0 is on our graph where y is equal to 0. We look at the value of our function and we see that we have a y value of 5. So we know that f at -18 is equal to 5. Okay, so once we know our cycle or we know our period, we can use that to go forward or backward cycles that we can actually tell the value on a graph. Okay, so that's our introduction to periodic functions. Tomorrow we're going to take a look at some specific periodic functions that we